All right, last week we worked on the tire and the wheel. Now we're going to go right behind these four bolts and work on the hub. So where is the hub in our list? Let's go look for it, HUB. These are all the things that we purchased. Here's where we purchased it from, Amazon. And the piece we're going to be designing is just the one that has the four pieces sticking out. Next week we'll be working on the bearing and the C-ring and the brake rotor. But today only, or this week rather, only going to be working on the hub. Let's see if I have a good picture of it. Yeah, that's probably a good one to start with. The things we learned about standards and engineering last time for the wheel is that there's four bolts, and then we know that they were spaced out by 156 millimeters in a circle. So let's just start with that. So new sketch. That's our suspension. Work on it later. And we're going to do this in millimeters just because we only know that one number. Um, the 156. I think that's what it said, right? 156. Yes. And so let's see. I don't think we're working on that object. We're going to be working over here. And away we go. So circle, and we're already in millimeters, 156. Let's start with that. And let's just put one circle on it and then try to design our way back from there. When you have a 12-inch bolt, and that's really what we have coming through the wheel into the hub, you're going to need an opening that's bigger than 12 millimeters. I hope I didn't say 12 inches. I meant to say 12 millimeters. So it's an M12 bolt with a pitch of 1.5. So we need some allowance here of 14 millimeters to allow that bolt to go through. And then the lug nut is going to fit on the outside of that, which we will talk about another time. Now I'm wondering if this one feels like it needs to be along the vertical axis, and it does. So to straighten that out, I guess what you can do is click on either horizontal or vertical and say, I want this one to be locked in here so that it is fully defined. And so what we'll do is we'll make a shape that goes around here, and then we will do a rotate to show our symmetry. This turns out to be only needed for just finding the location of the centers of the circle. So we don't need to have that be a real line. In fact, I think you can make it like a center line. Is that the one? Okay, we'll come back to that one a little bit later. The other thing we noticed is that there's going to be an arc that's like this, and I want to make it purposefully wrong, going like that. And then we need to go get a measurement for that. Let's see if we can get some kind of measurement from the internet. So if we look through some of our diagrams, this is the research part of what we're talking about today. Let's see if I can find a good place for images. There's some more Baja stuff here. Do I have some here? There's a picture of it, but here's some right here. So I guess the dimension that we know would be, I guess we need something that is the diameter of that one. So the diameter of this piece right out here. And the thing about Polaris is that they will not really give you the CAD files for these because they want to protect their design. So this is why we're designing it ourselves, is to try to come up with a model that we can put into our 3D model simply because Polaris can't or doesn't want to give that to us. This is kind of nice that they give us some of the dimensions, however. Okay, I wonder if that right there might be enough. It looks like they're saying that from here all the way out to there is 17.8 centimeters. Let's see if that makes sense in our drawing. 17.8. And for this one, what we would be doing is going from the very edge right up at the top. And I don't see anything that's there. So I'm going to make a point right here. And I need to be going from here all the way down to here. And it needs to be 17.8, so 17, okay, 700, 100, so that would be 178 millimeters. I think divided by two because that would just be half of it. And that does not look big enough. So I don't think that that is a good number to go with. And so the point of me showing you these things here is that, when you do your research, you have to go with what's reasonable. And so the other thing I just realized is that I was measuring the diameter right here, whereas they were measuring the another dimension. So let me see if I can get to their dimension instead, um, and see if that makes sense. I just assumed that that was the radius, but apparently it has a different point of view. Let me just close this one out, pause the video. All right, so I got some numbers, but this still doesn't look right. So what do we do when we get to that point? More research tools, you're not given the model of it because the company doesn't want to reveal it to you. So you have to find these workarounds. And so we will insert a screenshot and do a little bit of reverse engineering as we've done before in this class. And so we'll go to the desktop, get a screenshot of the hub, put it up here, and let's make it to look like it's to scale. And that would be, I think I can just take a point, put it here and there, because this is the one distance that we know, right? Is the 156, the standard distance between, well, it's the diameter of the circle on which the holes reside, 156, right? Now the thing is that did not resize accordingly, so let's go ahead and load it up again and make it work. So I've learned that if you move the image around, it doesn't really uh, adhere to what you expect. And by that, I mean, if you start to resize hole placements on its surface, so I'm going to click here, put a hole here, and one right there, measure the distance between the two, then pull this out, 156, but it still didn't change its size either. So that's kind of odd. I wonder if it's when I put it at the origin. Of course, the other thing we could do is just grab this and bring it out to that point, but it seems like it's really not a good idea. So I'm not gonna give up on this. I know that y'all don't have to be doing this at this time, but it's something that someone has to do in order to get the research figured out. So this time what we're going to do is try the trick of putting it at the origin and see if it locks it in some way, so that if we put a point here and a point here, approximately, you notice I did that, and we want the diagonal to be 156, and it still didn't do it. Can I pull this out to that distance though? I guess that's going to have to be good enough for what we want to do. Not really. I swear this worked on another one. So when in doubt, just kind of get another picture so that way you can maybe make the measurement on the other one. So I'm almost certain this worked out in the problem that we worked last week. And that is you place the part. See how it's behaving a little bit differently now on a new part? And then we put the points here and there. I might have been on another sketch in that previous diagram. Let's see if this will take it, 156. And it did this time. All right, so now what we can do is actually measure the size of that circle. That's what we really needed. So we're going to put a circle approximately right here and go out that distance right there. And you can see it's about 63.6. That's all we really needed. So let's go back over to this part and delete these images. And hopefully you didn't even put those in there anyway, because I'm doing this, at least this part of the research for you. So I want you to measure this one right here to be, where did that circle go? There it is. 63.7. Now that was diameter, so we're going to divide by 2 to get radius, and that looks a lot better as far as what we're looking for. So all you really need to have on your diagram right now is 156, 14, and 31.85. Then we start to bring the rest of it into reality by um, having a vertical line. Let's just put it right there and do another one over here as well to try to represent the way that this is. Maybe make it in line with that one because we're trying to represent the way that we see it. So by that, I mean, looking at this diagram here, right there. So we see a straight part of it right here. So let's go over there and make that adjustment. And let's save our part. Call this hub version 2. And save that into your Baja directory. At this point, we can go back and edit the sketch now that you saved it. Because in order to save it, it has to close the sketch. And we just say edit again. All right, we can rotate it back around like we had it if you want, and make some simple constraints. One of them is that we want this dot and these two dots to be on the same horizontal line. Now the question is Z going to be this one? No. Or is it going to be this one? Yes. So we go like this and that, and like this and like that. And then we go ahead and connect our points right here and there and there and there. So we're seeing this start to take shape right here. All right, so now let's go ahead and measure some of these hole sizes that are inside of here. We have a hole that's right there, another one there, and so basically a hole or edge and another edge right there. Probably another edge here as well. Now they give you a few dimensions on the internet to work with. Like this one right here is 44. But let's just go back to our other approach, and that's just taking this as a scaled drawing and getting some rough measurements from here. So let's draw some circles. And this is going to be our first one. That's around 30.5. This one right here, I think should be around 44, as we just saw on the internet. We go out to this one right here and out to that one right there at the very end. Then what we can do is right click and say, hide this image and get a few of these measurements. And I'm going to get these measurements for you. So there's the hole placement. This is for the arc that we were talking about. But the things that we need is the size of this hole, 30. Let's just say 30.5 to make it easier for us. We're approximating our scale. We know from the internet that this one's actually 44, at least according to the last drawing we saw. This one right here, we'll say 68.5. And the outermost one right here is 112.6, I think. All right, so now I've got to remember those numbers as I'm going into my circles over here. So let's make 1, 2, 3, 4 circles. We'll go 30.5 and the 44 first. 3.5, 44. I like how that keeps it fully defined. Then we'll go to 68.5 and 112.6. The thing we know about these circles is that that middle one is a hole, And then this right here is actually the base. So we need to, I guess, extrude this downward because maybe we can do is call this like the plane of the object, and so we will extrude downward from here to see if that's maybe a good start. All right, so let's start with an extrude at this point, and we'll take this and we'll extrude downward. And let's see if I can get some measurements from the internet to tell you how far that's going to be. Let me pause the video. All right, after doing a little research online, we'll edit this one right here. And we determined that we need to go 47 units in one direction. And that one's going to be downward. And let's see which one that's going to be. Here we go. 47 millimeters. That needs to be the other way. 47 that way. There we go. This one needs to be 4. And so the bearing is actually going to go around this cylinder, the bearing that we're going to describe, that we're going to work on next week. I'm going to make the rest of this sketch visible again so we can start using some of these other features. So the next feature that we're going to have is this one right here. It's also going to be extruded up and down as well. So we need to go to that donut, and I need to get you those distances. You could pull on this a little bit that way and kind of get it to be close to what we're seeing over there. So right now we just have that little ring here, and we're working on this one out here next. That's what this is out here. But it also extends somewhat into the part this way. Let's see if it'll let me grab that. It's kind of in there, isn't it? Maybe not so much. All right, let me give you those two up and down measurements. Let me pause the video so I can get you that. That's the research part of this. Okay, and the research that I'm getting from the internet tells me that I need to do my next extrusion. So we say edit this one, and we need to add a plus sign so that we're doing this one next. And we need to go up 17 and then down 14. And so the bearing is going to set right down on this right here and push up against that one. So we got part of this one being drawn. You can see that we're building up the bearing from there. I'm sorry, the hub. Now you also see that this one right here, it kind of goes up a little bit. Let's see if we can get a side view. Yep. So you can see it kind of, I guess, gives you a taper almost from there to there. And that this meets up with that circle. So let's see if we can pull that off. We say this meets up with that circle. There it is. So let's edit the sketch and use that phrase. This is coincident with the circle. So now you can see that that's the shape that we have right over here. And we'll extrude this in a little bit to get that plate thickness. Okay. But for now, we need to make a taper from here down to here. I'll let you make that design on there if you want to. That's a nice challenge, but I think a better challenge would be for the splines on the inside. So at the end of this, I'll challenge you to do that part. All right, let's see if we can make a taper. It's been a while since we've made a taper. So let's go to complete this, see where we're at, and the taper needs to go from right here down to there. So right here down to here. We might have to have two different sketches for that. Let's see what the taper tool is going to require. Usually you have to maximize this to find taper, or I'm sorry, loft in this case. It says find the first sketch. And it might let me do this one. It might let me do that one. But it didn't seem like it really did what I wanted it to do. Yeah, so I'm afraid it's going to require some different sketches. So let's go up here to the top of this one and say new sketch. And the only thing I want on there is this outer ring. To make it easy, I just project that geometry onto this one. And I say save, and so there's my sketch number 2. So I do think that the lofts have to be on different sketches. So we start with this one, And we go down to here. And then we click OK once we get everything secure. Let's see. Missing something. Okay, check this out. When we attempt to make a loft and we use this one, it says edges. But when we try to click on this edge, it clicks everything. It even shows everything in the list. So that's not how we want it to behave. So it looks like we have to do yet another sketch. Now, I think we're on this plane here. Which one? That one? Yeah. So then we just say, let's make a new sketch here. This will be our third sketch. And all we got to do is project that circle onto the plane that we're on. That would be the sketch number 3. Let's hope that works and that we have 2 yellow things like that. We can actually hide sketch number 1 momentarily just to verify that we can make that loft. And look at us go. All right, so now we got the loft there, but it looks like it forgot that we had a hole there in the top of it. That's weird. Okay, let's see if there's a feature within the loft command that will allow us to not select everything. Maybe it's the closed loop option. See, it put sketch number 3 there, so that's not right. Oh, it might be right because I think there's only one thing on sketch number 3. Should be only one thing on sketch number 2. And feature failed. Let's see if we can tell it about this one right here. Edit sketch. Project geometry onto that surface. So now we have those 2 yellow circles. I'm trying to learn how this loft behaves in our software that we're using. So you can see I did that, and now I'm going to say, make sure it's a closed loop. And it says, no, you can't do it. Hmm. Now, it might be just a limitation as to how the loft behaves. So maybe that surface and this edge, and then does this change it? And if that keeps filling in like that, then you just fall back to revolve. So sometimes, these tools don't work out like we want them to. So if we go to the front view, like this right here, just use the revolve tool instead. So if we go and draw a picture on, let's see, this plane, go to this plane right here, new sketch, and we can just draw our triangle that we will revolve around. Of course, we could have done the revolve and then drilled holes in it, but it just seems like too many steps for that. Let's see if the revolve will work now. So we need to go for that shape. And we'll see if we can pick the axis that is this direction, which looks to be the y-axis. And there we go. And see how much easier that is to get that loft in there. Let's not forget that sketch number 1 contains some of the stuff that we need. So we'll go back over here and say make that visible. Getting closer to the end of this one. Okay, now we need to go about extruding this into a plate. And we want to extrude it downward only. 8 millimeters. And we also want to select this material right in here as well. So that makes the bottom plate all the way around. And you might be wondering what we're talking about. We're talking about this and then that thickness of the plate that goes all the way around here. Okay, I still got to make the bottom, but we're almost done. Let's go ahead and multiply the feature times 4 or 3, whatever the number is. Let's say circular. And we want to extrude that pattern that we just created. But we want to also revolve it around the y-axis, which is the green one right there. But we only need a total of 4. And now we have our hub, folks. So now I'm going to hide this one. and hide any other sketch that might be obstructing our view of a clean shot at this. Okay, looking good for a hub. Okay, the only other thing that they have left over to do on this one is the bottom part. So let's flip over and go to this side right there and take a look at what the internet can offer as far as revealing about what the bottom of it looks like. So you look right here and you get the biggest, best shot of it here is that there's some kind of material around here. And do we know how far it goes up? Yeah, roughly. So let's just make just one of those cylinders first, and then we'll do this unusual shape. And I think that will be all you really need to do after that. I will challenge you then to put 26 teeth in the middle of this using the revolve tool. That's called a spline, and that connects to the half axle. But let's just put a simple ring around this and extrude it upward, multiplying it by 4. So let's draw on the surface. And going out like this. If I remember right, we are at 23. Is that right? Wait, where'd it go? So right click, new sketch, circle, 23. Oh, there it is. Okay. Now, I hope it recognizes that that is already a projected surface. It did in my case. And then we extrude this upward right here, but not the entire thing. So clear that out, select only the donut, and we need to go up 20 like so. Let's multiply this times 4 by using the revolve tool. Circular pattern. Select the shape. Select the axes. And you only need 4. Okay, it looks like the rest of this we can kind of freehand in based on what I'm seeing. I mean, it would be nice if it was just a box, right? Like if it was just a square box, but it looks like they give a little bit of a style to it. So we will do that same thing as well. You can add that feature if you want to, but we're just going to end with this part, and then I'm going to challenge you to do the spline in the middle. So new sketch right here. And on this new sketch, what we want to do is project the geometry of the outside of this one and the outside of this one. And then we're going to take a circular arc, and we want to have it be a 3-point arc. And if you hover over that, it's going to tell you to pick 2 points, and then you get a chance to adjust the middle one. So we're going to say select this point and select this point, and then just kind of curve it in a little bit like so. And now I can see why they wanted to curve it in. They wanted to have it meet up with that right there, or maybe go a little bit over that. So that's starting to make sense as to why they would want to do that. For our own benefit, we can make this one tangent to this one tangent to this one, and just make sure that it doesn't go over in that area. And then the rest of this would be an offset. Now, let me measure what this was again, because I already forgot. That right there is 4.5, okay? So that means we need a 4.5 offset going in this direction, like that. Okay, where'd it go? It's there, okay. Okay, now we're going to extrude that one up the same distance, and then rotate that around. Look at that. Beautiful thing, right? And we're starting to see some of the design elements that the folks that made this, we're starting to see the reasons why they made some of those choices. Once again, we select the y-axis until we only need 4. There you go. There is our hub, folks. Beautiful. Absolutely beautiful. Let's make this out of aluminum. So let's go over here to hubs right here, iProperties, select physical, and then select aluminum. And you see it even has an aluminum look to it. Make sure you save that right there and upload that into D2L. But make sure that you also add this line in here. So make you 20 something teeth in there. What was it? 26 teeth. So cut them to be, I'll just approximate them as maybe, well, I'll just let you approximate them and make it look good. You know, in other words, you don't want the teeth going all the way to the center. That would be not realistic. You see, here's the bolts that we normally use for the lug nuts that go through there. All right, I'm going to do one more step. I'm going to save it as a step file. This part, I want to show you how we ended up using something like this. So we're going to save this one as a step file. Maybe we have to go and say export instead. Save, say, add this one. Is this how you select it as a step STEP? Sure enough. So here's a new format. There's STL. I really want the STEP right there. All right, we're going to save that one to our normal directory with that name of hub2, and then we're going to go over here to hubs.com. I want to show you how much this one costs. I'm going to get a quick quote. What do you think? $100, $200? Let's find out. So I got my own account here with Hubs, and I bought a lot of stuff from them, and it's pretty expensive. And I'm going to show you how we did some cost savings on this one. So here's a new quote. And it's going to tell us to upload the file. I think it takes SolidWorks files and maybe step files. It's going to be a CNC machining file. Oh, look at there. There's the IPT. I didn't realize that. So we select that one. We go over to our inventor location. And it's working on it. And then for some reason, it doesn't show the date modified. And so let's see if we can get our hub up to the top. There it is. Oh, it already loaded the step file, but that's okay. Either one of these is going to be good. Did it just give me an error saying that it couldn't do it? Let me do that again. I think I just clicked on it too quickly. Okay, well, we'll get this one this time. Okay, does your file contain any of the following? Oh, no. Okay, it thought I had proprietary. It's asking if I had any proprietary information in there. And you saw that I basically was just guessing from the internet as I did this one. Okay. Yeah, development and testing purposes in our case. I don't know what the error would be on this one. It couldn't detect the 3D geometry. Okay, so apparently it didn't like the IPT file. So we will try a new version of it instead. And if it doesn't work, then we'll just call it. But we're supposed to be able to just trash that one and delete quote. And it will pull in that step file, which is what I thought I needed to do. I normally use SolidWorks files though. All right, to speed up the process, I'm going to go back to hubs.com and say get an instant quote. Site's a little bit slow. I'm going to select the file again. There's a step file right there. Let's try it again. Maybe I shouldn't be so click happy, so I will read more carefully. Now building the quote. Yeah, just demonstration purposes in our case. And let's see. So now it can see the part file right there. It can do analysis, and now it's about to price the part. I am going to guess that it's going to be several $100s. And sure enough, if we wanted it like an economy shipping, it's $400. Okay. And this is if we want to get it here in 9 business days. So, and that's kind of the cost of doing custom work like we're doing right here. So if we had to make a custom hub for our Baja that was just, you couldn't buy it online, then it would cost a lot. And that's what happened during our first Baja vehicle. However, what we decided to do is go with these custom, not custom built, but standardized parts, the hub right here, and check out the price, 142. And that's for 2 hubs. And it also includes bearings, C-rings, and the brake rotors. So we ended up doing this one so that we wouldn't have to go through and do the machining and do the cost here. So that's a little study, a little bit of research into how you handle cost management. And this is something you can do when you get into your projects as when you get into your company that you work for later. As a project manager, you'll be able to do things like use these resources to get quotes or figure out if it's easier to get off-the-shelf parts instead. Hope you enjoyed this video. Hope this was a little bit easier than the last few projects, the hub, and yeah, go ahead and upload that one, and I'll see you in the next video.